Greetings, my wonderful scholars. I'm Mr. Okafor PC, your online physics teacher. Our topic of interest today is conversion of units of area. Conversion of units of area. Recall, area is a derived quantity derived from fundamental quantity called length. When you have two lengths, you talk of area. When these lengths are unequal, it's also area. Then we can now say that area is length times length, or length times breadth, or length times width. Area is two dimension. We consider two lengths. Length is one dimension. Okay. Most times in external exams, students are expected to convert diverse units of area to meter square. To meter square or squared meter. Because the most acceptable unit of area is meter square or squared meter. You see, students are demanded to convert from units like decimeter square, millimeter square, centimeter square to meter square, the most acceptable units. That is why we've chosen today's topic as area of interest. In the course of today's lesson, you will learn how to convert with ease from diverse units of area to meter square. Okay, let's go back a bit and talk more on area. Area is when a body extends in two dimensions. Okay. Let's take this book for example. The surface of this book has what we call surface area. It has area. The book, first of all, extended in this dimension, after which it extended in the other dimension. So the book has two extensions in space. At the surface of the book, we have two extensions in space, and that's what we call area. Extension 1, extension 2. The longest side is called length. The other side is also called length. But if they are unequal, like we can see, this is a rectangle. So we can call the shorter length breadth or width. If they are unequal, one becomes the breadth, the shorter one becomes the breadth or the width, while the longest one is also called, retains the name length. So the space covered by these two extensions, here is equal to there, here is equal to there. This space covered is what we call area. Area is not a line, it's a space covered by a line. The perimeter describes the area. And we say the formula is length times breadth to give us area, to get the space covered. So this is what I mean by two dimension. The surfaces of all bodies come in area. The surface area of this book is area of a rectangle. Then we also have another extension in space. The spine of this book. The spine, the thickness of this book is another extension, the spine. But that is three dimension when we begin to talk of volume. But that's not our concern for now. We're just concerned with two extensions here, the length and the width. Okay. Okay, this is another surface. This time the surface is circular. This time it's a circular surface. Okay. So we can now say that the area here is pi r square. The area is dependent on a constant pi and the radius, a straight line from the middle of the circle, center of the circle to any other point at the circumference. So the area here is a circle. This is a circular surface area. Then this is another example. This is a meter rule. A meter rule also has surface. You can see the surface. It makes two extensions. Extension 1 and extension 2. Extension, or to take it from here, extension 2, which is shorter than the first one. Therefore, the space covered there is the surface area. But recall, we are concerned with the units of measurements. The unit of measurements of area. So let's see how to convert these diverse units of measurements to the most acceptable unit of measurement, which is meter square. Okay. Take for instance, we have 20 decimeter square. And we're expected to convert to meter square. Okay. Recall, 20 times the word deci. The word deci has mathematical equivalence. The word deci has mathematical equivalence, which is 1 over 10. But if you don't take time to observe what I'm about to say now, You will do mistake in your conversion. So take time to listen to what I'm about to say. In decimeter square, the square there, the square is for both deci and meter. Decimeter is like a unit. It's like a single thing. So the square there is for both deci and meter. So deci will get its own share of square, and meter will also get its own share of what? Square, like you see on the board now. Then the word deci stands for 1/10. Give it each portion of square. Square it. Job well done. Then the remaining thing is meter and its own portion of square. And that's the final units. Then the mass is done already. Just do the arithmetics. Then we'll go on. 20 times in the laws of indices. The fractional index law says, if you have a fraction and there is a power, the power is both for the numerator and the denominator. The numerator and the denominator share the power. Let's see. 1 times 1 or 1 square is 1 over 10 times 10 or 10 square is 100. 100. Then go on with arithmetics. 0 cancels what? 0. 2 key self 1. 2 key 10, 5. Therefore, 1/5 meter square. Okay, you can see that 20 decimeter square is the same as 1/5 meter square. Conversion made simple. Okay, let's take another unit. Let's go for centimeter square. Okay, let's maintain the same number because our consign is at the units. Here we have 20 centimeter square. Recall the word centi has mathematical equivalent. Centi is 1/100. We go again. 20 times centimeter square. Recall that is square. The square will be distributed between centi and meter. We have 1/100. Give it its own share of square. Then give meter its own share of what? Square. Job almost done. Then go on mathematically. We'll be having 20 times 1 times 1 or 1 square. 1. 100 times 100 or 100 square will give us 10,000. Then meter square. Then do your arithmetics. 0 cancels what? 0. 2 keys itself 1. 2 key 10, 5. So we'll be ending up with 1/500 meter square. So you can now see that 20 centimeter square is 1/500 meter square, the most acceptable units. Then let's try millimeter square. Recall, milli stands for 1/1000. Give milli its own portion of square. Then drop that of meter. 20 times 1 times 1, 1/1000 times 1000. 1000 squared is 1 million. Drop the meter square. 0 cancels 0. 2 key self 1. 2 key 10, 5. The answer becomes 1/50,000 meter square. You can now see that 20 millimeter square is the same as 1/50,000 meter square. Conversions of units of area. Please, the most important thing here to recall is that your decimeter square, centimeter square, millimeter square, no matter the unit squared, that other one that has mathematical equivalent, that word problem like deci centimeter that has mathematical equivalent must have its own portion of the square. Never forget. You must give it its own portion of the square for easy conversion. Then there is this other unit of area called hectare that we see in real estate. Where in real estate, hectare, hectares of land. It's also units of area. It's also a measurement unit for area. Hectare. Okay. 1 hectare is 10,000 square meter. 1 hectare of land. 1 hectare of land is 10,000 square meter or meter square. Okay, it's a very simple idea. See, sometimes you also need to carry out measurements yourself to confirm what your quantity surveyor has said. Okay, let's go back to this analogy. This is a meter rule. This is a meter rule. What you are seeing here is 100 cm in one dimension. This part, this extension in space is 100 cm. 100 cm. And 100 cm is taken as 1 meter. Remember, we're concerned with meter. So the whole of this is just 1 meter. 1 meter. Okay. Then let's see if this meter rule were to extend equally in space. Let's say I have this way 1 meter and also that way 1 meter. Then let me put on the board what I'm trying to say. Okay, let's say the first time, this is the meter rule. I want to contract it, to reduce it. This is 1 meter, the whole of this. Then I also take it this way, the whole of this way. This is also 1 meter. Please don't mind the shape. Those are straight lines. So the meter rule has taken one line and again another line, giving me a perfect square. Then let me see how many area this meter rule will define for me, or the space it will cover. If the same meter rule goes in this extension and that extension, I'll be having area of 1 times 1. Recall for finding area is length times length when the sides are equal, or length times width when they are unequal. So the length here is 1 meter times 1 meter. 1 times 1 is 1. Meter times meter, meter square. So just a box described by this meter rule in equal extensions, a box of it. If I should make a box from this, it's just 1 meter square. Then you ask yourself, if 1 hectare is 10,000 meters square, then how many buses? How many buses of this meter rule will be there? How many buses? Just 1 meter square. We're just 1 meter square. A box of this is just 1 meter square. Then let's see how many buses here will give us 1 hectare. It's a very simple idea. Then see how we do it. Then let's get a bigger box, the complete box that we call 1 hectare. Okay, let's pretend that this line is 100 meter rules. This is just 1. For me to get 1 hectare, I have to get this meter rule, then throw it on a single line. I have to get 100 of it. Just 100 of this meter rule. Throw it on 1 line. 100 of it. Then when I get to the ends, I will mount post there. Then I'll take the second dimension again and throw 100 of this again. So 100 of this meter rule by 100 of this meter rule again will give me 1 hectare. Are you getting the idea? So I'm trying to tell you that if you can get this meter rule, 100 of it, or you get a mechanical tape to make it easier. But if you get 100 of this, or you get this single one and go on a single line 100 times, you count as you go 100 times and stop, then go to the other second dimension, go 100 times again, then cover the box. What you have there is 1 hectare, because that's what will give you 10,000 meters square. Let's see from the board. So one of these, I've multiplied it into 200 on this part, so I have 100 meters. This part again, 100 meters. So the space I've covered there is 1 hectare. Then let's prove it. Area, length times length. The length here is 100 meters times 100 meters. The second extension, area is equal to 100 times 100, 10,000. Meter times meter, meter square. Meter square. So you can see that measurement is actually simple. It's just the difference between being informed and not being informed. So 1 hectare is getting 1 meter rule. 1 meter rule. Throw it 100 times on 1 line. Anywhere you stop, face the second line adjacent to it, or face the other line perpendicular from it. Throw another 100 meter rule. Cover the box, you have 1 hectare. So to tell how many buses that will be here, it's a very simple assignment. Since we have 10,000 meters square, I have just 1 meter square. You can do your what? Your division to know how many buses that will be there. Okay, we'll go back to our area. We can now say since the total space here is 10,000. What the total space here from our solving is 1. So I'll be having 10,000 buses here. So if I can create one box from this equal extensions, I will need 10,000 of that box to get 1 hectare of land. Okay, I want to believe that you understand that 1 hectare is equal to 10,000 meters square or square meter. I want to believe that you've learned that in conversion of diverse units of area to meter square, that no matter the units, since it comes with square, that square will be shared between the meter and that word problem like deci, centi, milli to make a proper conversion. Dear scholars, please stay tuned on this platform as we go on to making physics and measurements simple. Thank you. Please do subscribe.